Hey everyone, my name is Dikari, and for the screencast of chapter 18, I have chosen a problem from our book, and the question goes as um, just let me zoom in. A dipole consisting of point charge of positive 4 nanocoulomb and negative 4 nanocoulomb separated by a distance of 2 mm is centered at location this meter, and a hollow plastic ball has a radius of 3 cm and charge of negative 0.2 nanocoulomb which is distributed uniformly over its surface is at location this meter. So what is the net electric field at location C at this position? So this is a really rough diagram that I made where you can see the dipole, the charge ball, and the location C where we need to find the electric field. I'll just give you a slight definition of the superposition principle that we discussed in our class. We know that the superposition principle, from the superposition principle, that the net electric field at a location in space is a vector sum of individual electric field contributed by all charged particles located elsewhere. So that means that the electric field at location C is the sum of individual electric field contributed by this dipole and by the charge ball. Someone phone is ringing on the back. So as I said earlier, E net can be given by electric field by the dipole and electric field by the ball. So let us calculate the electric field by the dipole at the beginning. So we know that the distance from center of dipole to observation location can be given by observation location minus the initial location, and after doing the calculation the value comes around at 0.11 meter. We also talked about this thing in the class where we made the approximation that if C is reasonably far from the dipole, the magnitude of dipole field can be calculated by this formula, where S is relatively smaller than R. So using this formula, where E equals 1 upon 4 pi epsilon naught to QS upon R cube, we get a value of 108 Newton per coulomb. We can also consider the ball as a point particle, because since the charges are uniformly distributed over its surface, so we consider the ball as a point particle in our problem. So now, in order to calculate the electric field by the ball, first we calculate the distance from center of ball to the observation location, which can be given as before. So putting the value, we get a magnitude of 0.136 meter. And now calculating the unit vector, which is given by direction upon the magnitude, we get a value of this much. And so now the electric field due to the charge ball can be represented by the formula where we use for a point particle, which is E equals 1 upon 4 pi epsilon naught Q unit direction upon the magnitude square, and putting the value, we get a value of this much. And as I said earlier, the net electric field is given by E net equals E dipole plus E upon ball, and putting the value, we get a value of this much. This is barely a rough diagram that I made that might be useful while doing this calculation, where you can see the dipole, the ball, and the point. And since the electric field to the dipole will be on this direction and electric field by the ball will be on this direction, we can consider the electric field E net on C to be on this direction.